alkali metals. That is the group 1 of the elements. They have all 1 electron in the outermost shell. They are all silvery white, and they are reacting with water and with air. With water they form alkaline solutions. Potassium is used in fertilizers. Lithium, components of lithium can be used to treat manic depression, and lithium together with aluminum makes a strong and light alloy, which can be used in airplanes. And then some things more are said here. There's been said that we're all reacting with the water and with the air. For example, sodium is reacting with the air if there's a fresh cut in it, and it tarnishes, and therefore these alkaline metals are stored in oil. Potassium is reacting even stronger with the air. When we say that potassium is reacting strongly with water, the other ones also, and if it reacts with water, it zooms then vigorously over the surface of the water and forms hydrogen bubbles which are burning in a pink-blue flame. And then the potassium, the alkali metal, and the water forming potassium hydroxide. And the next thing we then said is that then calcium and francium, I think was it, are exploding if they're coming together with water. Now these 6, they are lithium and sodium, and then potassium, and then rubidium, calcium, and francium. Now there are sodium atomic clocks, something, it's not explained 100% how it works, but there is calcium atomic clocks. There's calcium that is then heated, and there's said calcium vibrates with 9,192,641,770 times per second. If the calcium is heated, it travels somehow with splitted off atoms, then through an electromagnetic field, and that tells the clock what time it is. They said how sodium is made. They said there's salt taken. Salt is sodium chloride that is heated in a Downs cell to 800 degrees Celsius. Then electricity is going from the anode to the cathode through the heated sodium chloride, and then it is split and separated. And then there is said that there are sodium lamps, and these are used as street lights, and there is a sodium vapor in, and if now the electricity goes through the sodium vapor, then that glows in a yellow color. And potassium hydroxide and sodium hydroxide can be boiled together with fat to make sound. And that is according to Susan McKeever's Science Encyclopedia book on the page 34. This is no chemical advice, and the positions and views expressed are the ones of the source and don't necessarily align with my own or the ones of the entities spoken of. And welcome. I'm trying to learn chemistry today, alkali metals, and after we've done that, we're going to do tiptoe yoga. And if you participate in the tiptoe yoga, then it's at your own risk. And this is the third part. And now we want to go into the lower side. What was it here? Making sodium. Sodium was one of them. It was the second one. Lithium, sodium, potassium, rubidium, calcium, francium. The alkali metals, first two. Now what is the ring? It's to make sodium. Sodium can be extracted from salt, which is sodium chloride, using a Downs cell. So whatever a Downs cell is, within it, someone can get sodium. And sodium is a part of common salt. The salt is heated to 800 degrees. Okay, we're having salt, which is sodium chloride, technically, heated to 800 degrees Celsius to make it melt. And when it is melting, like other things as well, like snow would be melting at 1 degree Celsius, or sugar is melting at, I don't know, 150 or something. And salt is melting by 800 or something. Electricity travels through the molten salt via two rods called a cathode and an anode to make it separate into sodium and chlorine. Okay, let's go through the illustration. Where is electricity going through it? Sodium chloride is fed in. Okay. Chlorine is giving off. Chlorine comes out as a gas. Is chlorine a gas? Isn't it called chlorine gas? So the chlorine is here. So these are the noble gases. So I assume this is a gas. Non-metals. Let's assume it is a gas. Why should be salt consisting out of sodium and chlorine? I heard that the reaction of which forms when salted with chlorine and sodium is a pretty strong one. And the reason for it is, I think, if I remember, it's very long ago, was that they are so far apart on the periodic table. Let's assume chlorine. No, let's not assume it. Let's take it as a possibility that chlorine is a gas. Chlorine is given off here, the green thing. Molten sodium is thrown off here. Is thrown off. Molten sodium is somehow there with the red thing. Okay, sodium is molten, chlorine is gas and comes out. Molten sodium chloride. Okay, sodium chloride comes in, which is salt. And it melts when it has this fluid form. Sodium is reduced at the circular steel cathode. The whole thing is the cathode. Okay, the whole thing here, the silvery thing is the cathode. And there the sodium comes to it, and then it is drawn away with the red thing. And chlorine is produced at the graphite anode. And that is graphite, the black thing. And there comes a chlorine too. Okay, electricity comes through. So there is a big, what is it called? A big whatever, a big, I don't know any names of it. A big block full of molten sodium chloride, like water. And through that now the electricity is coming through the cathode and the anode. The cathode and the anode in the middle, and through them there's electricity going. Through the cathode and the anode. And now the sodium comes to the cathode, the silvery thing, and is then drawn off from it, the sodium, and that is a dot cell, and the anode at the anode the not graphite. The anode is out of graphite, and there comes the chloride in, and that seems to come then out as gas, and that thing is a dot cell, Downs cell. Electricity travels through the molten salt. Okay, from the cathode to the anode, or anode to cathode, via two rods called a cathode and an anode. Where are the rods? Why do we have such a metal fancy, whatever it is? Electricity travels through the molten salt via two rods called a cathode and an anode. We continue to assume that the silvery thing is the cathode, and the other thing, the graphite anode, is the anode, and that there are no rods or wires, because I can't see them. And that separates into sodium and chlorine. He has not explained why, I don't know why, but it has something to do with it. Electricity is taking the one thing and the other thing not. Because electricity are moving electrons, and they're taking no. Sodium has different amount of electrons, it has 1 at the outermost valence shell, and chlorine has 7. So chlorine has 7. Chlorine goes to the anode where the electricity comes in. Whatever, it has something to do with it. It has 7. It gets one from the, I don't know, it gets one from the electricity, and when it goes to the electricity pole, and when it is there, it is something about that. It's not explained here. I don't know why, but it has something to do with that. This process is called electrolysis. It was first carried out by Humphrey Davy in the 19th century. Okay. How about we reading the Celsius atomic clock again? Whereas again the half not so clear. Clocks keep time by counting some kind of level, such as the swinging of a pendulum. Atomic clocks count the natural vibrations of calcium atoms. Scientists know that calcium atoms vibrate at 9,196,631,770 times per second, so fractions of a second can be measured by accurately using this clock. The vibrations are detected with the help of an electromagnetic field. Calcium is heated so that it gives off atoms. Atoms traveling through an electromagnetic field, giving a reading on the clock. And where are the vibrations? The vibrations are not the amount of giving off. How fast is it giving out? Or is it given out so far? Or how fast is it given out? Is it given out with 9 billion? It can't be, that sounds way too much, but how fast is it given out? How fast are these rates? I think they're talking about this half-life rate. Now there are some which have a pretty long one, millions of years or something. But there are also some which have a very short one. I don't know which one were more dangerous, more reactive. And after that, half of it is there. How does it even happening? Is it just... So it must... Because I try to find out what these vibrations are. It can't be that it is just sitting there for 100,000 years and that it's splitting and it's only half there of the radioactive material. So it must be going something out all the time. How can there coming 9 billion parts out? And by calcium, we are certainly not talking about something which has just a few seconds of time until it's only half left there. Otherwise, it can't be used in a clock for at least some days. What are these vibrations? How can there be atoms given off? If there are atoms given out, the way we're talking about it, it sounds like whole atoms. But if a whole atom comes away, what if someone has just one atom of calcium? How could that one atom then make its to half? Probably through the vibrations. But okay, another thing which we don't really understand because it's not explained. What else do we have here? Alkali metals are soft enough to cut with the knife. Sodium reacts so quickly with oxygen in the air that the cut surface tarnishes within minutes. Potassium reacts even faster. The rubidium and calcium explode as they touch water. Okay. That was it. We have it now all together. I think I'm able to make a presentation and then say what they said here and give a little overview and then say what the Humphrey Dumphrey cell is. The down cell invented by Humphrey Davy. Now I think that I'm able to make a presentation. If you, reading it a little bit more, if you were here for chemistry, you can go directly to the next part of biochemistry, where we're gonna go a little bit over 2-3 things again, and then I'm trying to make a presentation and try to say as far as they said that to the calcium clock and the sodium, whatever, the down cell and the other things. If you were here for that, you can go directly to the next part. If you stay here and participate in the tiptoe yoga, then it's very good. Everything together, breathe in the arms and come up onto the toes. Out and down. In and up. Down. In and up. Out and up to the side. In and up. Out to the other side. In and up. Make an inch of space between the feet, out to the side. In and up. Out onto the other side. In and up. Out and down a bit. In and up. Out and down a bit. In and up. Out and lean onto the knees. You can go with the heels down. Breathe in. And out, make a head with the back. In into the middle. Out, make a belly with the back. In middle. Out here. Middle. Belly. Middle. And out, come with a round back, up a little bit backwards. Shoulder. In the arms up onto the toes. And breathe out and sink down. This can go onto the knees. In and up. Out and down. In and up. Out, hands down, heels down. And the legs standing a bit apart. One foot points in front, the other one to the side. The heels are standing on a line. In the arms up. And breathe out, bend the front leg and come up onto the toe. Breathe in and reach in front. Out, lean back. In and straighten the front leg. Out and down. Middle, heel, other side. Breathe in. And out, bend the front leg, come up on the tiptoe. In, straighten the front. Reach in front. Out, back. In, straighten the front leg. Out and down again. Arms down. And the legs a bit to the side. In the arms up on the tiptoe. Out and sink down. You can do it also with the heels down. In and up. Push something heavy, imaginary upwards. Out and down. In and up. in and up. Out and down. And one more time. In and up. Out, hands down, heels down. Have the feet same together. In the arms up on the toe. And out and down. Breathe it in. And out. Bend the right leg, stretch the left body. And change. Stretch the right one. Middle again. Open the feet to the side, keep on hanging down. Breathe it in. And out, go over to one leg. Breathe it in. And out over to the other leg. Again in. Out into the middle. And close the feet. Breathe again in. And out, keep on hanging down. Again in. And out, come slowly with the round back up. Back at the top and backwards. Shoulder. In the arms up. Bring the hands to touch and lower them down to heart center. That was Tiptoe Yoga. I thank you very much. And next time.